Hi everyone, Architecture and Operating Systems module. We are in week 7 and we've got two worksheets for this week. Worksheet 7, which is about DeMorgan's theorems, and worksheet 8, which is about simplification. The first one, which is worksheet 7, Boolean algebra and DeMorgan's theorems. So DeMorgan theorems is one of the most important rules that we have in Boolean algebra. And it's important because it can convert AND gate to OR gate, and OR gate in the opposite way to the AND gate. So we can actually use AND and OR gate interchangeably, but under a condition. What are the conditions? The first theory of Demargon is A naught or B naught, it's equal with A and B naught when we invert them. It means that if I have A naught or B naught, it's equivalent with A and B. You can use NAND gate or say AND not. So A naught, B naught, or is A and B not. So we can convert AND to or to AND, but when we have these inversions. So I can use it both ways. So if you have A and B not, immediately you can say that because of this not, I can actually expand that to OR gate, but each input should be inverted. This is the first theory, which is very important. The second theory of Demargon, it's opposite. 2. Here I had A naught and B naught, it's equal with A and B naught, but in the second theory it says that A naught, B naught equal with A or B naught. Again, here I've got AND gate. First one is not A. Second one, not B, equal with A or B. Not or NOR gate. Again, AND gate converted to OR gate. So these two rules are very important. So before I solve a couple of questions for you to show you how we use these rules, it's better to write them again. So I've got two rules for Demargon theorems. What are they? It's A naught, B naught is equal A or B naught. The other one is A naught or B naught is AB naught. So guys, we can use both rules from either directions, no difference. So I'll show you what I mean. Example 1, I want to solve 3 examples, but these rules are important and I want to keep it up here. The first example is this one, A and A or C, all of them not. So guys, look, what I see here is A, this is one input and the other input. Also, I can tell you here that guys, A and B, I can write, for example, the first rule as this. As, for example, circle naught, triangle naught is equal with circle plus triangle naught. And the second rule can be written as circle naught plus triangle naught is equal with circle triangle naught. It means that each of them can be multiple inputs. Here, for example, I can say this is my circle, this is my triangle. Same story. So what I have, A or A and A or C, all of them not. So I can use which rule? I can use the second rule, second theory. Why? Because this is my circle, this is my triangle. Look, exactly similar to that. These two. What I get? The inversion of the first one plus, because it converts this AND gate to OR gate. Conversion of that, which is A or C not. Look, each of the inputs will be inverted. So it's equal. A naught plus. I see A plus C naught. Look, guys, this is very similar to the second rule that I have. A B naught, or here is A C naught, A or C naught. So it's equal with A naught B naught. Here it's equal with A naught C naught. So I got rid of all of these brackets and everything. So guys, in the simplification, always remember that our aim is to get rid of the brackets, because if we get rid of the brackets, then we can apply all the rules that we have. So what I can do here, now I can use, let me put the formula sheet for you here. Yes, actually I can use this formula sheet that I will upload it to the Moodle shortly. There you go. Good. Now, what I can do, I can use rule number 10 here. Rule number 10 says that A or AB is equal with A. In the previous video, I explained that. And we discussed about the common factor. So here, that can be my A, that can be, and this can be my A in the rule 10, this can be my B in the rule 10. But if you are not sure about that, this is rule number 10 that you can use. But if you're not sure about that, what you can do, you can say that, okay, I see the common factor of A here, A naught. Take a common factor, distributive rule here, distributive rule. You can take a common factor. Look, you have got A here. I can take a common factor of A. From the first one, 1 remains. From the second one, C naught remains. A or C naught, this is what rule? There you go. This is rule number 2. This is rule number 2. This is an OR gate. One input is 1. The output is definitely 1. So it's equal with A naught and 1. A naught and 1, this is the rule number 4. It depends on A naught. So this, the output is A naught. Here you could directly say that, okay, this is A naught or A naught C naught. It's similar to the rule number 10, which is A plus AB. The answer is A. The answer is A naught. So what is important? I use Demargon's rule, and I could show you that A and A or C naught is equal with A naught. Look, we massively simplified this circuit. This is one example. The other example that I want to solve is this. Example 2. Is A naught or B naught or A plus B naught? Whenever I see this structure of the Demargon, A or B naught, so I've got the Demargon rule here, guys, for you. Look, I've got this structure. A or B naught, I can immediately say that it's equal with A naught plus B naught plus Demargon. A or B naught is A naught, B naught. So what I can do, then I can take these two. This is A naught plus A naught B plus B naught. Again, you can take a common factor of A naught, or you can use rule number 10 again. Same structure, A or AB. Here, rule number 10. A or AB is A. So A naught or A naught B naught is equal with A naught plus B naught. But if you wanted to know, okay, what factorization, you could say this is A naught, take a common factor, you get 1 plus B naught, which is 1 here. This is A naught and 1 is A naught. So the answer is A naught plus B naught. As you see, we get the same answer. So by only using the Demargon theory here and get rid of this bracket, I can use the other rules here that we have in the rules and simplify that circuit. My last example is number 3, which is a b naught plus a naught plus a b, all of them not. So this is a good example. Whenever I see the bracket a b naught, there you go, guys. This is another rule. I want to get rid of the bracket. Whenever you see not on top of a bracket, you can use Demargon rule. So this is equal with a naught or b naught plus a naught plus a b. So in rule number 5, we say that rule number 5, R5, we don't need to repeat any input. So I get rid of one of them. A naught plus b naught plus a b. Now it's very interesting what I've got to do. I write it equal with a plus a naught plus ab plus b naught. And guys, look, this is rule number 11 for me. In rule number 11, I have a or a naught b is a plus ab. So I'll write it for you here. Rule number 11, it says that a plus a naught b is equal a plus b. But here, instead of a, if you replace it by a naught, you get a naught plus a naught naught b is equal with b a naught plus b. So it means that only I change the input. So I get a naught plus a b is equal, ab is equal with a naught plus b. This is rule 11 that you can apply here. This is one of the most important rules. So guys, look, these rules, we can use them as a position of the inputs. We can actually have AND gate instead of each input in these rules. So you should be able to use them in different ways. So if I apply rule number 11 here, what I get is a naught plus b naught, but don't forget, all of them are in the NOT gate here. All of them are in the NOT gate. NOT gate. So I've got that now. This is b naught. So b or b naught is what? Look, guys, rule number 7. Rule number 7. B or b naught is definitely 1. Why? Because always one of the input is 1. When you have b, if b is 0, b naught is 1. If b is 1, b naught is 0. Definitely in OR gate, we've got this 1 here. So what I get is a naught plus 1 naught. Again, I've got a naught. Actually, directly here, you could say that the whole thing is 1, because when we always have 1 here, I don't care about the others. But you can actually do 2 by 2 like me. Again, this is rule 7, and I get a naught or 1 is 1 naught. What is 1 naught inversion of 1 is 0. It means that, guys, using the Demargon rule, I could show you that the whole thing here is always 0. So in this short video, I try to explain you Demargon rule and solve 3 good examples. Please watch them, do the exercises, and actually learn these 2 important rules. I will have another video for this week that I will provide you very soon. Thank you.